So, hello everyone. Welcome to the post-contest discussion of Coding Club NIT Silchar of Codechef. Let's start this contest. The first question is spell shortening. The problem is given like this. Chef is attempting to learn magic but is really been aging well. In order to pass an upcoming exam, Chef decides to memorize magic spells. But even that turns out to be too hard. A magic spell is quite simply a string that consists of only lowercase Latin letters, that is the characters A to Z. Chef has come up with a magical spell S and is struggling to remember it. To make things easier, he decides to delete exactly one character from it. After all, a small modification to the spell won't change its effect, right? Chef believes he has a better chance of remembering this spell if it is lexicographically smallest. Can you help Chef find which character he should delete so that the resulting string is lexicographically smallest among all possible results? So basically, the question says that you will be given a string and you need to erase exactly one character so that the string is lexicographically as smallest as possible. So based on the intuition, also we can identify that we should remove a character s of I such that s of I is greater than s of I plus 1. If the next character is smaller than the current character, then delete the current character and just print the remaining string. Now let us see why this works. Since we can iterate through the string from the front, so for the lexicographically smallest string, the smaller character comes first and is responsible for the overall smallest order of the whole string essentially. So the character which is nearer to the start is the most influential character. So if we delete the character which is greater than the next character, then it will be lexicographically minimum than the original string. Hence, we delete the first occurring character that is larger than the next character so that we can achieve the most lexicographically smallest string. So another case arrays. If we reach the end of the string, it means that all the characters are in the lexicographical order. So in this case, we just remove the last character to essentially make the string smaller. If you look at the test cases here, the first test case is BA. So what we are doing is we are trying to find the first character which is greater than its next character. Here B is the first character which is greater than its next character. So we just remove the B and print the remaining string A. And here the string is in the lexicographically smallest order. So we can just remove the last element here. Here M is the character required character. So we just remove the M and print the remaining string. Here R is such character. So let us see how to implement this thing. We just take the value of length of the string and the string as input. Then we find the index where this is occurring. We loop from 0 to n minus 2 and we find if at any position I, s of I is greater than I plus 1, s of I plus 1, then we just mark the I in index and we break from the loop. If index is minus 1, that means the string is already in the lexicographically smallest order. So then we take the index as the last index and we take the string answer and we run a loop from 0 to n minus 1, and if I is not equal to index, we just add those character to our answer and we just print the answer. This can be implemented in other ways also. It is one of the possible ways to implement this problem. Our next problem is not prime permutation. So here you are given a permutation P of integers 1, 2, 3 and so on n. You need to find any permutation A of 1, 2, 3 and so on n such that for every index I from 1 to n, ai plus pi is not a prime number. If no such prime permutation A exists, print minus 1 instead. Note, a permutation of 1, 2, 3 and so on n is an array of length n that contains every integers from 1 to n exactly once. So there can be many solutions to this problem, but the simplest one is I will now explain the simplest one. So it is given that ai plus pi is not a prime number. We need to construct a sequence pi. So let us assume that pi is equal to ai. So then ai plus pi becomes 2 times of ai. The definition of a prime number states that it is a number which is not divisible by any other number other than 1 and itself. So when 2 into ai is divisible by 2, Hence it is a composite number. Hence we can find the sequence in this way. But there is an exception to this thing. If a is equal to 1, then 2 times of a will become 2 and it is also a prime number. So in order to solve this thing, the exception only occurs at when a is equal to 1. So if we swap the elements 1 and 3, then whenever there is 1, the pi will, whenever a is equal to 1, pi will become 3, and whenever a is becomes 3, pi becomes 1. The sum a plus pi becomes 4, which is a composite number. So if you look at this particular test case 25134, we assume that a is equal to pi. So pi will become 25134, except we need to swap the positions of 1 and 3. That will be a valid sequence. One more exception is that when n is less than or equal to 2, when n is equal to 1, the only number in the sequence is 1. So such sequence does not exist which satisfy these conditions. And there are cases when n is less than or equal to 2. 2 plus 1 is 3, which is a prime number. So the answer does not exist. To implement this question, we just take the input of n. We just take the array's input. If n is less than or equal to 2, the solution does not exist. So we just print -1 as output. And now we need to swap the positions of 1 and 3. We can swap them by finding out both those indexes and swap them, or much simpler version is this one. We just iterate from 0 to n minus 1, and if a is equal to 1, we change it to 3. Else if a is equal to 3, then we change it to 1. We just make sure that here not another if condition is mentioned. If another if condition is mentioned here, then a will becomes 3, again a becomes 1. So we need to write if and again else if here to make sure that both does not get executed at the same time. Then we can just print the array here. And that's all about the second question.
Hello, is my screen visible?
Yes, it is visible.
Okay. So in this problem named equality etiquette, we are given two integers a and b, and we would like to make them equal. But to make them equal, we can perform several moves. On the ith move, we can either add if I is odd, we can add I to a or add I to b, and if I is even, either subtract I from a or subtract I from b. Once again, we aren't allowed to subtract from both. You must choose one. In first move, you add 1 to either a or b. In second move, you subtract 2 from either a or b. On the third move, you either add. So basically, what we can do is we if I is odd, we add it to a or b, or if it's even, we then subtract it from a or b. So and in the question, it's said that you have to print -1 if they can never be made equal. So one thing to notice is that there won't be any case when the answer will be -1, because they can always be made equal. Suppose we are given two numbers like 1 and 4, uh, then we can always add 1 to 5, then so 1 to 4, so 4 becomes 5, then we subtract 2, so it becomes 3. So the difference decreases by 1. So if the difference we call the difference as d, then at 2 times d we can always find the answer. So there won't be any cases when the answer is -1. So let's just without any loss of generality, we just consider the difference to be the absolute difference between a and b. So these are basically in this code. Let's just run through the code and just understand along the way. So when the difference is 0, so we can just output 0, and the 1, if the difference is 1, we can always just like suppose if the difference, suppose a is greater than b, and so b is less. So one thing to notice is that if difference is d, so what one operation does is either add 1 to a or add 1 to A, so this increases the difference by 1, or add or subtract add 1 to B. So this if we add 1 to B, so it decreases the difference by 1. And similarly, if it's for the minus, so it does the same thing. Basically, if we decrease it, suppose for the minus, if I say about the minus, suppose A was here, B was here. So if we subtract minus 2 from A, so we basically decrement the difference by 2. If we minus 2 from B, we basically increment the difference by 2. So basically, if D is, let's consider D. So one way I found it easier to write was that suppose D is basically something we either add the difference 1 to it, or we subtract the difference 1 from it. So it will be something of the order something like this. There will be a few terms plus minus k, and at the end the difference has to be 0 for them to be equal. So what we can think of it is, if let's just consider the sum of 1 plus 2 plus 3 plus till k, right? So this, as we all know, it's a standard, it's equal to k into k plus 1 by 2. Now one thing we can notice is, suppose if k into k plus 1 is equal to the difference, we can just like uh, follow this sequence of order and achieve 0, achieve difference equal to 0 by like adding 1 then subtracting 2, like the sequence of order that makes it 0. So if it's k into k plus 1 by 2 is equal to d, then we can just like directly get the difference. Now what if d is not of the form k into k plus 1 by 2? One way to think of it is that if it is not k into k plus 1 by 2, so basically suppose let's take an example. Suppose we want to we have d is equal to 13, so like the case is something like a is equal to 1 and b is equal to 14 or something. So the difference comes out to be 13. So if we write from 1 to 2, 3, 4 and 5, this sum comes out to be 15. But we actually want 13 here. So what do we want? We want to decrement this sum by 2. But now to decrement this sum by 2, actually what we have to do is, instead of adding this 1 to the difference, we subtract 1 from the difference. So what this actually does is, suppose we decrement it from the sum, and it also contributes twice. It contributes twice because earlier we were considering it in the sum. So we reduce that, then we again reduce it because it changes its parity into minus. So this sum actually turns out to be 13. So if suppose it's 15 and we want 13 and the difference is even, that is like here it's 2, so we can always find a number which is half of it, that is 2 by 2 is 1, and we can change the parity, like we are taking plus 1, so we are adding this to the difference, but now we subtract it from the difference and we can get the sum 13 in 5 steps. uh, in 5 steps. Now what if the difference is odd? If the difference is odd, that is, suppose we want we have like 1 plus 2 plus 3 plus 4 plus 5, but what we want is 14. Now the difference is 1, but we cannot subtract like 1 from the sum, because if we subtract 1, everything just doubles. It's doubles its equivalence in the sum. So like even if we subtract 1, it actually becomes 13. If we subtract 2, it becomes like it becomes 10, it becomes 11. So basically, so now this won't be the optimal answer. Now if we consider one more element, if we add 6, so the sum now becomes 21. 21 minus 14, it's still 7. It's still odd. So we can't get the optimal answer here as well. Then we add one more element plus 7. Now we are guaranteed because of the how the parity works. So if we in this case we got odd till here, then we added an even. So now the parity remained conserved because we added an even number to it. But now we added an odd number, so the sum now becomes 20. 15 plus 20 plus 7, so the sum now becomes 28. So now 28, now what you have to do, uh, now since the sum is 28, 28 minus 14, it becomes even. So we can change the parity of 7 here. So we can subtract 7 instead of adding to the difference. So this brings about a change of minus 14 to the sum, and we actually have the solution in 7 operations. So that's how the solution works. So these are the trivial cases here. I just initialized answer to 2 strict d because we can always have the answer as 2 strict d. Then I ran an infinite loop from the square root of d. So basically, we want the sum to be either greater than, we want the sum of the series k to be greater, let's call it sum. We want the sum to be either greater than equal to the number, the difference, right? So if the difference becomes, we check, so I iterate from, the sum is basically k into k plus 1 by 2. So it's roughly k square. So I just iterate from root d. So I iterate from root d, and if uh, if the sum of the series 1 to k, if it's less than d, then I just continue. If now if it's greater than equal to d, now I check the remainder. So c is nothing but the sum from 1 to k. So if the sum is if the difference between c minus d, that is the sum minus the difference, if it's odd, then there, like, we will find some better optimal answer in the next two parities. At max we'll need next two numbers, because if we even add even number next, then the parity remains conserved. Then after that we add an odd number, so like we always get the answer there. So I just ran an infinite loop till we get the such parity, because I know it won't take, like, it will take at max 2 or 3 iterations more to find the answer after we get a odd difference. So I just ran an infinite loop. This won't go to infinity, because we just break when the parity becomes even. And if the parity becomes even when I is equal at I, so that means with I, when k is equal to I, we can actually get the sum in I turns. So that would be the answer for this question. So now I will be explaining this question, spread spree. So in this question, we are actually given a n cross m matrix, uh, in which we can color at most one index, one grid, one cell of the grid. Now how this it's actually depicted quite well here. So in the first, we colored here, then it spreads one round around it, and it propagates through the grid until all of them are covered. So one thing we can notice is that, suppose we color this grid, the maximum if we color this grid, the amount of time we color this grid, with the amount of time taken to fully cover the entire grid, will be the maximum of this distance, this distance, this distance, and this distance. So if the index, because it's like in every second it's like moving one layer at a time. So the maximum of this will be the amount of time it takes to actually fully cover the grid. So we can actually find now uh, so if we can see that n and m don't really matter here, because the if we even turn the grid upside down, the answer will still be same. So let's just run through the solution. So what I did first is, if n is less than m, I just swapped n and m, so that without loss of any generality, n is always greater than equal to m. So the maximum distance, in this question we are given that if k is equal to the what is given, if is the minimum value of f of I comma j across all grid of ij. F of ij is nothing but the amount of time taken. So across all, the minimum will be minimum value across grid, there is a minimum time required for the entire grid to have black cells. So suppose if this is the grid, then the minimum time will be the max of this, as I said earlier. So that part is given by suppose now since n is less than m, I always swap n and m, so n becomes greater than m. Now if n is odd, so if n is odd here, so if it's 5, suppose it was a 5, it had 5 uh, rows, 5 columns or whatever. So here the middle element will have the least time here. So that becomes, that is nothing but n plus 1 by 2. So as you can see here, suppose there are five rows, and n represents rows and m represents the columns. So here in this column, in this row, we will have the minimum distance here and here, because if we move up, this just increases, and if we move down, it also increases, right? So this we can check that if this is the index 1, this is 2, then this becomes 3, this becomes 4, this becomes 5. So in now let's again consider the case when it's even. Let's consider the case when it's even. So let's say uh, n equal to 4. So here there are 4. So this is row number 1, this is row number 2, this is row number 3, this is row number 4. So here if we take this, the distance is this amount, the minimum time required for the entire grid to be colored is this amount. And if the if we consider this, the answer is still the same, right? So we in case of even, we can consider two rows. Two rows will contribute towards the answer, and in case of odd, only one row contributes to the answer. In the question, we are asked to find the value of I cross j across all such ij's such that f of ij is k. So that means we have to find the uh, sum of products of all of the x and y coordinates of I cross j of the row number and column number of the cell, such that the minimum time such that the time required to propagate the black color from that cell is equivalent to the is equal to the minimum time required to color the entire grid black. So as we saw, in case if n is odd, so only one row contributes to the answer, and if n is even, both these two rows contribute to the answer. Now there is another thing. Suppose uh, let's consider uh, it's 6 cross 5, right? Okay, so let's consider this example only. uh, in this case, it's since n is 6, m is 5, so the maximum of so the time required will be 6 plus 1 by 2, 6 plus 1 by 2, that is the seal of 6 plus 1 by 2, that is nothing but 4, because if we color this, so as you can see, first, the second, third, and then fourth, it took 4 cycles, 4 layer movements to color the entire grid black. So the k value will be seal of n plus 1 by 2. So this is what I actually take here. Uh, so now we know that since it's even, so this column and this column will contribute to the answer. But now there will be a upper bound, there will be a bound for the column number as well, since if we consider this row or this in the row number as well, so if you consider this row, the amount of time maximum, the amount of time taken would be 1 2 3 4 and 5. So we can't actually take that. We have to we can take let's redraw this. So we have to take this column, this row, and this row. So this is the range. So these two columns and these two rows are the range for our for I and j, for the respective I and j that we need. So how? So now we can actually find this. So this is nothing but the upper limit. So let's call this maximum, and the lower, let's call this minimum because it starts from here. So let's call it the minimum, and let's call this the maximum. So we can see that minimum is nothing but, so if this is m, so minimum is nothing but m minus, uh, so it's nothing but m minus k plus 1. So if k here, in this case k is equals to 4, so m minus 2, m minus 3, m minus 4. So this is the range. We can actually have 4 here. So m minus k plus 1 will be the minimum range. But now if this goes beyond, suppose it was something like this. So in this case, we can actually have the entirety of here, because the limit will be somewhere here. So we have to cap this limit at 1, cap the minimum limit at 1, and the maximum limit at, similarly for the maximum limit, we can actually calculate it as 1 plus k minus 1, because it will be of k length. So 1 plus 1, 2, 3, and 4. So here. So let's erase this. So the range that we actually have, that is the minimum, that is here, the maximum, that is this, and the two columns that we had, because it's even. So this is the range, this is the actual range of the indices that we want, I cross j. This is the range. So here, as you can see, I just calculated, I just first swapped, then I found out the value of k, then I found the minimum, this layer. So this is maximum of 1 comma m minus k plus 1, and this is nothing but minimum of m comma 1 plus k minus 1. So this is 1, so 1 plus k minus 1, total of k length. So I have used modular integer here, so as to save me some time for the modular operations. So if n is odd, so now I have to do the casework here. If n is odd, so there will be only one column available. So the index of the column will be nothing but, suppose n was 5 here. So n is 5. So the index, this is the index of the column. So this is nothing but ceil of n by 2, or so it's basically this is the kth value. So it's 1, 2, 3, 4, 5. In this case, the kth value is 5 plus 1 by 2. So it's nothing but it's just 3. So this is the required in the case of odd. In the case of odd, the required index is k itself. Then, as you can see, it's a single row. It's a single row around here. Suppose it's 3. So it's this row. So we want the sum in the of a column in the range. Let's just draw the 5 one. 1, 2, 3, 4. Suppose this was the range. Since this is the range and this is the column, so we actually want the sum in this. Let's take another color. So we want the sum in this color, in this column, in the range from this is the minimum and this is the maximum, from minimum to maximum. So, and we want the multiplication of I times j. So suppose this is I, so this will be I plus 1, this will be I plus 2. So you want I times j plus I plus 1 times j plus I plus 2 times j. So we can actually just like add, take j common here and add I plus 1 plus I plus 2. So this is nothing but the sum of sum in the range from minimum. Uh, so this is nothing but the sum in the range from minimum to maximum times just the column number, that is k in this case. Uh, so we actually can take this like, so the sum of the values from 1 to 1 to, so this value is given by the sum in the range 1 to max minus sum of the range 1 to min, open bracket, the just index before minimum. So I have just calculated that value here. So this is max into max plus 1 by 2 minus minimum into minimum minus 1 by 2. So that's just gives the required sum, and I just multiply it with the k to get the answer for odd. Now when n is even. So like in this case, so there will be two columns that contribute to the answer, and there will be the same range that we needed in the odd case as well. So that range will be here. Suppose this is minimum, this is the maximum. So it's similar to the odd case. Just the difference is that in odd case we only had one column. In this case we have two columns. So what I did was for uh, so basically we can also write this as, suppose this is the sum will be the same. So this is nothing but, suppose this row is I, this is I plus 1, this is I. So this is nothing but I into, suppose if this is k, suppose the k value here is 4. So 1 2 3 4, so it's k and the k minus 1th index that we that is the k and k minus 1th index is the index of the columns that we actually need for the answer. So uh, here it's k minus 1, so it's 4 and 3 here. So this is the third index column and this is the fourth index column. So we actually want I times so k minus 1, so I just write 3 here. So I minus 3 plus I plus 1 times 3 plus I plus 2 times 3 plus I times 4 plus I plus 1 times 4 plus I plus 2 times 4. So we can actually see that this is of the form, if we take 3 common here, suppose uh, I take 3 common here. So if I take 3 common, it becomes I into I plus 1 plus I plus 2. And if I take 4 common here, so this also becomes I plus 1 plus I plus 2. So we can see that at the end it's just the same sum that we calculated before for the odd, I into I plus 1, I plus 1 plus I plus 2 multiplied by, just this time it's the sum of the column, that is 3 plus 4. So that's what I just did. It's the same value that we calculated here, but the catch is we just sum the value of the other two columns that we need, the kth column and k minus 1th column, and we just multiply it to the sum. So that gives the answer. So I just outputted the answer here. So that's the solution for this question.
ठीक है, मैं डिस्ट्रैक्ट हूँ। स्क्रीन दिख रहा है?
अभी तो नहीं दिख रहा है।
स्क्रीन सेट है, दिख जाएगा सर। तो क्वेश्चन का नाम है स्टिंगी एरेस। तो क्वेश्चन में स्टिंगी सबसीक्वेंस डिफाइन क्या है, जिसमें 2 इंडेक्स बी आई फॉर इंडेक्स आई, बी आई एंड बी आई प्लस अगर इक्वल नहीं है, if bi and bi plus are not equal, we have to take those as subsequence, and we have to remove the maximum length stingy subsequence. And this is a game, so every player will come and delete the maximum length subsequence, and it will carry on until the last move, and then the person who performs the last move wins. Okay. Let's do some observations on the question. Okay, the first observation on the question is the maximum length subsequence, stingy subsequence, is unique. Okay, let's take a subsequence. This is 1 2 1 3. Okay, 1 2 1 3. What will be the maximum length subsequence? It will be only for allies, for the first person. It will be only 1 2 1 3 because none are equal. For the above given example, the stingy subsequence, maximum length stingy subsequence will be 2 5 4 only, and it is unique. You cannot find another subsequence like this, like or three length, and it cannot be different from this. So this is the in most of the game question what happens, Alice or Bob performs the most optimal move, but in this question there are no like there is only one move possible, so that becomes the optimal one, so we don't have to choose between any moves. And the second thing to observe is after every operation, like after we remove the maximum length stingy subsequence, at least one digit from the array disappears. Uh, like for this answer, like for this subsequence, let's say if Alice performs the move, the first person performs the move, 254 will be will disappear. So the remaining array will be let's dry run it. Subsequence remaining. Remaining characters will be 3 4 4 4 4 2 4 5 4 4 5 4 it is 2 4 5 4 4 3 4 2 2s and 3 4. The second person will remove, the second player will remove again 4 5 4, so the remaining will be 4 4 5 4 4. So in every operation one at least one digit will disappear. So let's think if we can like simulate the whole game, because there are no like you don't have to choose between two choices, you just have one choice only, so we can simulate the whole game in O of n. How to simulate the game? Okay, so let's check what happens on the is in this given array. Okay, we have a frequency of 2 as 1, we have frequency of continuous frequency of 4 as 4, we have continuous frequency of 5 as 3, or we have continuous frequency of 4 as 4. So in each operation, one of these digits will disappear. So two after the first operation, like you can check here, the frequency will be t, like one will become 0, two, the digit 2 will become 0, so the count of 2 will be 0. So only 4 will remain, that is 3, and 5, there will be 2 occurrence of 5, and there will be 3 occurrence of 4, 2 occurrence of 4 after removal. So after the second operation, there will be frequency of 2, 1, and 1. After third operation, the frequency will be, we'll remove 4, 5, 4. So the remaining will be 4 only, equal to 2, 1. So you can see every time one of the digits is decreasing and it is disappearing. So we can simulate the whole game in O of n. How? We can just store the frequencies, continuous frequencies of each number, and we can just decrease one from the frequencies until it becomes 0. And what happens, we encounter like this 4 4 4 5 4 4 4. What will happen? The frequency is 3. After one operation, 4 5 4 will disappear, so the remaining will be 4 4 and 4 4. So the what happens in this case, the frequency of these two numbers get merged, because after this operation only 1 4 will disappear in each turn of the game. So what happens after one turn, these two frequencies get merged, so we'll simulate that operation also. So let's check out the implementation of the question. Okay, you can check, you can see at the first loop, I'm just storing the frequency of the uh, every digits, continuous digits of the array. Like here for this array, I'll store 1, 4, 3, 4 in the stack. I'm using a stack for the storing, and in this while loop, I'm performing like in every turn, I'll just decrease, like, delete the maximum length stingy subsequence. So what happens? I take out the top element of the stack. In this stack, a temporary stack, I'm storing the like remaining array after after deleting the maximum length subsequence. So I'm popping out the first top element of the stack. I'm decreasing it by 1 because you can, as you can see, every frequency will be decreased by 1 after each operation, because I'll choose this 2 and this 4 and this 5 and this 4, because all are like no, there are no like adjacent equal elements. So I have to decrease this 2 and decrease this 2 and this 4. I have to remove this 5. I have to remove this 4. So I'll decrease those frequencies by 1. Just like here, I'll decrease frequency of 2 by 1, then frequency of 4 by 1. And then I'm checking if the top, like after decreasing it, also like the frequency is greater than 0. Like after decreasing the frequency of 4, this becomes 3. So I have to include this in the remaining array, right? So if it is not empty, I'm checking if the stack is not empty, like a new remaining subsequence is not empty, and the previous element is equal to the current element. Like let's check this case 4 4 5 4 4 4. The frequency is 3 1 3 for the initial. After a operation, I'll remove this 3 to 2. I'll decrease this 2 to 2, and this 1 to 0. Uh, so what happens? Okay. So the frequency is of this 5 decreases to 0. So it doesn't get pushed in the stack, and I encounter this 4. This also get decreased by 2. So I have to add this to as, like I have to insert this to as 4 because uh this will be considered as equal element. So I can decrease only one element from its after its operation, because what will happen after this operation, it will become 4 4 4 4. So after this, I can remove only 1 4. So that is become, it will become 4 4 4. Then it will become 4 4. Then it will become 4. So I have to somehow merge these 2 and 2. So what I am doing is, if the stack is like not empty, so I am checking if the previous element is equal to the current element. So if that is equal, then I am adding